Have you ever just looked at your desk, or even just the air around you, and wondered what it's really made of? I mean, deep down. Well, it turns out it all comes down to the same basic building blocks. Today, we're taking a journey into the incredibly tiny architecture that builds our entire universe, the atom.
So let's just start with that one massive question. If you could zoom in, and I mean way, way in, past what any microscope could ever show you, what would you find? What's the fundamental stuff that makes up reality?
You know, the answer is surprisingly simple, but it's also incredibly powerful. Everything, and I mean everything, is built from just 3 ridiculously small particles. So, let's meet them.
Okay, so here's our game plan. First, we'll look at the atom's basic blueprint. Then, we'll get to know our 3 key players, the proton, the neutron, and the electron. And finally, we'll see how they all come together to make this one grand, amazing design.
All right, first things first. Before we can really meet the particles, we gotta know where they live. You can think of an atom as having 2 very distinct neighborhoods.
Right at the heart of it all, you've got the nucleus. It's this super dense, tightly packed core, and then surrounding that nucleus is the second region, the electron cloud. Just picture this vast, mostly empty space where our most energetic particle is just zipping around. So you've got this dense center and this huge, spacious outside.
Okay, let's meet the first resident of that nucleus, and you could argue it's the most important character in this whole atomic story. This is the proton. It's the particle that gives an atom its fundamental identity. So let's break down its profile. The proton has a positive charge, and it lives packed right inside that nucleus. But its number one job, its whole reason for being, is to define exactly what element an atom is.
And get this is totally non-negotiable. If an atom has 6 protons, it is carbon, period. If it has 8, it's oxygen. Always. You literally cannot change the number of protons without changing the element itself. It's like the atom's unique fingerprint.
Now, the proton isn't alone in that crowded little nucleus. It's got a partner in crime, the neutron. Think of the neutron as the stable, heavy buddy that adds some bulk and basically keeps things from flying apart.
The neutron's profile is pretty simple. Like its name kind of suggests, it has a neutral charge, 0 charge at all. It lives right there in the nucleus with the protons. And its main jobs? Well, it adds mass to the atom and helps hold that positively charged nucleus together.
Now here's where it gets really interesting. While that proton number is locked in, the number of neutrons can actually change. So an atom of carbon might have 6, 7, or even 8 neutrons. These different versions are called isotopes. They change how much the atom weighs, but they don't change its identity. It's still carbon.
All right, let's leave that calm, stable nucleus for a second and head out into that huge electron cloud to meet our third and final particle. This is the electron, the lightweight, super fast little guy that makes all of chemistry happen. So the electron's profile makes it pretty much the polar opposite of the proton. It's got a negative charge, and it lives out in that big, spacious cloud outside the nucleus. Its mass is so incredibly tiny, it's almost nothing compared to protons and neutrons. But its job is huge. It handles all the action through chemical reactions and bonding.
And this really shows you just how important they are. Electrons are kind of like the social butterflies of the atomic world. They're the ones that interact, that bond, and that jump between atoms. And it's that behavior that creates chemical reactions, forms molecules, and even allows electricity to flow.
So we've met our 3 particles, the proton that defines everything, the heavy neutron, and the superactive electron. Now let's put it all together and just admire the beautiful balanced system they create.
This table just lays it all out so perfectly. In the nucleus, you have the positive proton setting the element's identity, right next to the neutral neutron providing mass and stability. Then, way out on the outside, you have the negative electron driving all the chemical action. It's really a perfect division of labor.
And that balance of charge is so important. In a stable, happy atom, the number of positive protons is perfectly canceled out by the number of negative electrons. This makes the whole atom electrically neutral. Now, when that balance gets thrown off, the atom becomes charged, and that's what scientists call an ion.
Okay, get ready for this, because this fact is truly mind-bending. Because that electron cloud is so enormous compared to the tiny little nucleus, an atom is actually 99.9% empty space. That means the solid desk in front of you, it's almost entirely nothing. What you feel as solid is just the electrical repulsion between the electron clouds of your hand and the desk. Wild, right?
So, why does all this tiny stuff matter?
Well, because these three little particles explain pretty much everything. They explain why we have different elements like gold and oxygen. They explain how all chemical reactions happen. They explain how electricity powers our world, and even how stars shine by fusing atoms together in space.
So let's do a quick lightning round of the key takeaways. Number 1, protons are positive and they define the element. 2, neutrons are neutral and they just add mass. 3, electrons are negative and they control all the reactions. 4, protons and neutrons hang out in the nucleus. And 5, electrons are zooming around on the outside. Got it? Good.
It is truly astonishing when you stop and think about it. Our entire, vast, complex universe, from the smallest living thing to the biggest galaxy, is all built and governed by the elegant dance of just 3 tiny particles. Their rules are simple, but their impact is absolutely universal.